Okay, yeah, the title of the presentation is The Need for Speed, What is GraalVM? How many of you have heard about GraalVM before? Most of you, so what are you doing here? Just joking. How many of you are developing Java software or JVM-based software for cloud? Some of you, okay. So now I get it. I know why are you interested in this presentation. Okay, to start, a few words about me, Maciej Przepióra, or Mac, for English-speaking people. That's easier to pronounce, and I'm used to it. By education, I'm a molecular biologist. I finished biotechnology on University of Warsaw, and I went straight from the lab to the coding desk immediately because computers were my hobby since I was a kid. I learned to program in BASIC when I was something like 10 or 11. So I was always having fun with computers. So it turned out that I'm a software developer. In the free time, I'm also trying to do some homebrewing, not much of it, since I've got 2 small kids at home, and you need something like 6 hours straight to do the complete brew, to brew the beer. So not doing that too much recently. And I work for Spartas. Have you heard about Spartas? Yeah, it's a smallish company that is located in Gdańsk. And we're an Atlassian Platinum partner, which basically means that we develop Jira and Bamboo for Atlassian. We developed the server version of those 2 applications. I'm a software developer at Spartas, but I don't work in Gdańsk. Actually, I'm a remote developer. So we have one remote team that is completely distributed. Interesting. I would say that I don't wear only pants to work. Have you heard about this book, A Year in a Pant? That's a really good book about working remotely. I would recommend it. Okay, but let's get to the point. Let's talk about what we're going to talk about today. The presentation plan is very simple. First, I want to talk about the status of JVM, of Java Virtual Machine, and in particular, what is the status of JVM in the cloud. And my point here is that I want to convince you that GraalVM is important because more and more software moves to the cloud, and GraalVM is the answer for Java in cloud. Okay, then I'm going to talk about what GraalVM is internally, so basically how it works, what are the cogs inside the GraalVM. So a disclaimer here, this talk will not, I won't code during this talk. This talk will go into some computer science and information science details. If you're not interested in that, I won't mind. And then the final point on the presentation is it worth your time? Should you look into it? And if so, how to get started with it? So, yeah, I'm sorry. Yeah, what is GraalVM? So basically, most of you probably already know it. This is a new just-in-time compiler devised for Java Virtual Machine that is supposed to replace the C2 compiler. As you probably know, the just-in-time compiler in JVM, in the stock Oracle JVM and most of the JVMs that are available, it's actually 2 compilers, the client compiler and the server compiler. The client compiler takes your bytecodes, Java bytecodes, and compiles them to native executable code as fast as possible, just to have a good bootstrap time, right? And then after the JVM warms up, that's what we call it, after some warming, C2 kicks in and optimizes the most reused code path, right? And GraalVM is basically thought of as a replacement for the C2 compiler. Okay, so what's the current status of JVM? Why do we need something like GraalVM? And another disclaimer here, I'm gonna talk some controversive stuff here, so please don't get offended. I've got two controversies already shown here. One is that Java is slow. Who thinks Java is slow? Excuse me? Yeah, that's the point here. So the bootstrap time of Java applications is slow. When the JVM warms up, it can achieve very fast performance. I mean, it can be on par with C++ code or Go code or whatever, but it needs this warm-up time. And that's why I say that if someone asks me, is Java fast or slow, I would say, of course, it depends, right? That's the stock answer, the best answer you can get. It depends. If we're talking about bootstrap time, then Java virtual machine applications are rather on the slow side, right? If we're talking about the performance, once the JVM warms up, it gets better. But what is the reason for bootstrapping time being so low and so slow? Well, in its heart, JVM is a stack-based virtual machine that interprets bytecodes, right? So that was the reason it used to be slow all the time. Like 20 years ago, when Java started, it was slow all the time. It wasn't just that it bootstrapped slowly. It hasn't had the just-in-time compiler. But the answer to this problem was that HotSpot was conceived, right? So HotSpot, which has been around for the last 20 years, it has been very fine-tuned, and it gave us very nice performance. Like for the last 8 to 10 years, I would say Java performance is okay, right? And that's the problem. On the other hand, HotSpot has been around for the last 20 years. The point here is that it has become a legacy of Java virtual machine, right? The problem that people developing HotSpot in Oracle is that they don't get many new developers. They can't onboard new developers to HotSpot development because it's C++ code. And one of the guys told from this team, he told that they don't teach C++ anymore. They teach Java. So Oracle had a problem with developing HotSpot, and what they came up with is that they would want to rewrite it in Java, right? And that's one interesting thing about GraalVM, that most of it is actually written in Java and not in C++. So it's easier to work with it. Then, the other problem with HotSpot is that it is optimized for data center deployments, right? That's because HotSpot was an answer to a problem for data center deployments, right? When people were using first application containers, like, I don't know, earlier versions of Tomcat and so on and so forth. The problem was that the applications were running very slowly. So that's why the C2 was born, and that's why Java is optimized for, currently is optimized for this kind of deployments when you have long-running applications, long-running application servers, right? So you boot up the application server, you drop a WAR file or a ER file into it, and then you don't expect to restart it in, I don't know, in months, right? But this is a problem because that's not how cloud works, right? So that's my third controversy, that Java is not cloud friendly. Would you agree? Who would agree that Java is not cloud friendly? Not many people. Why do you? So a question to people who don't agree. Why don't you agree? Why do you think that Java is cloud friendly? Okay, well, there are things like, for example, Spring Boot Cloud, right? Very nice tools for developing Java in cloud, right? There's Netflix OSS. That's true. There are really good tools for developing Java applications for cloud. And AWS, Google Cloud, all the cloud enterprises, they're providing support for Java in cloud, right? But the actual model, yeah? I mean the JVM itself, right? Well, we're getting to the point why GraalVM is needed, right? But one of the most important reasons is that currently the JVM itself is not very cloud friendly. It has a long bootstrap time. It doesn't like things like, well, it wouldn't work very well if you had, I don't know, an application that needs to scale very well, and you have a very dynamic throughput, right? So you get very high spikes, and then you need to drop the instances that were just spinned off, right? For example, I don't know, a good example for that would be Lambda, right? In Lambda, you don't know if the instance that was spun for you will go away in minutes or in hours, right? So you don't get all the benefits of HotSpot. And that's why I think that the JVM, the stock JVM from Oracle or OpenJDK, it's not very cloud friendly. Okay. The other thing is that until like something 2 years ago, JVM wasn't aware of Docker. There was a huge thing about JVM not being aware of Docker and the limits that it imposed. So when JVM was trying to grab, for example, more memory in the container, it would only look at the memory available for the whole system and for the host system and not for the container itself. And this was fixed only 2 years ago. Okay, so as I was saying, things have changed from DC deployment. Instances come and go away. So what we need is low resource utilization, right? We need unattended execution, and that's one of the reasons why HotSpot was replaced with GraalVM, or is going to be replaced with GraalVM. And then a fourth controversy today, a side controversy, I would say. Java might not be the best language in the world. Who thinks so? A surprisingly high number of people think that Java is not the best language in the world, given that this is a Java Developers Days conference, right? But anyway, again, it depends, right? It depends on what you need to achieve, right? If there is some problem that would be better solved with functional programming, I don't know, Clojure, Scala, why not do it, right? We've got tools for that. Or maybe you like Ruby and would like to code part of your application in Ruby. There's JRuby, I know about it. But the point here is that alternative JVM languages are gaining more and more in more popularity. And one of the interesting regions is data science, right? What are the most widely used languages in data science? Python, right, and R, and maybe Scala. Maybe not really. But anyway, let's say that you have a huge system that is being developed in JVM-based languages, and then you need to drop some data science into it. What you could do, well, you could do the so-called polyglot programming, so develop the system in different languages so that you can use the right tool for the job. And, well, this is possible on JVM, of course. We've got Groovy, we've got Scala, we've got Kotlin, we've got Clojure. And there's some natural part of the JVM that makes it easier to do the polyglot programming, which is the bytecode, right? The bytecode is the actual universal format for JVM. So it's not that hard to come up with a new language that will just compile to bytecode, right? And the point here is that doing polyglot programming on JVM is much easier than doing polyglot programming out of JVM. And why is it so? Because when we do the out of JVM polyglot programming, let's say that we're separating a service out of our system, that is going to be written in Python, right? The problem here is that we've got inter-process communication involved right now. We need to pass the data from one process to another one. Maybe over network, maybe over shared memory. That doesn't really matter. The thing here is that it's going to be really slow. Well, you could argue that Java allows us running native code through Java native interface or Java native access, right? So we can drop a shared objects library and then write some glue code in Java and use it in the same process as the JVM. But then I wouldn't recommend it because it's really hard, especially Java native interface. So the other thing is that who would want to stitch, let's say, R and Python in one process using C-based glue code? I mean, you don't want to go there. There are things like global interpreter lock in Python and so on and so forth, right? So the nice thing about JVM is that it's a really nice platform for developing polyglot programming environments. And then the other problem that GraalVM tries to solve for you is, what if you want to come up with a new language because the ones that are existing don't suit your needs? Who has come up with their own language? No. Oh, there is one person. Okay. That might be interesting for you. But anyway, so what is the process of coming up with a new language? Well, usually you come up with an abstract syntax tree interpreter. You need to have a parser for it. Then that's how Ruby used to work. That's what Ruby used to be, right? It was just a simple parser that took the input, tokenized it, created an abstract syntax tree, and then walked through this AST. Then the next step is in implementing a runtime for your language. You need things like garbage collector, implementing threads, and so on. But people will complain that this is slow, right? So what people do when they hear that their new language is slow? Well, let's have a bytecode and a bytecode interpreter. This will probably make things a bit faster because you can optimize it more. And then once you've got the bytecode interpreter, the usual path is that you get a just-in-time compiler, right? And that's how Java, basically, that's the story of Java, right? It started as a bytecode interpreter, and then there was a JIT compiler added to it so it could be faster. How many of you have expertise in writing just-in-time compilers? Me neither. I mean, there is not very many people in the world that know how to write just-in-time compilers. So if you want to come up with a new language, the other thing that you might want to think about is a foreign functions interface so that you can use C libraries, right? That's what, well, I don't agree with that, but that's what they tell about Python. Some people say that it's just a thin wrapper around C, right? But anyway, if you want your language to be successful, you probably also need a foreign functions interface so that you can integrate libraries written in some other language, like C, C++. In case of JVM languages, that's a bit easier thanks to bytecode interface, right? So it is easier on JVM because we've got the bytecode as the universal interpreter. Also, actually, we've got bytecode and bytecode interpreter on the JVM, and we've got a just-in-time compiler on the JVM. So what we really need is just a parser and AST interpreter, or we just need a compiler, right? That will compile our language straight to the bytecode. Okay, and that's how things like Groovy or Scala work. They just compile down to the bytecode. Okay. The only thing is that you might hit some issues with the bytecode that you emit in such case. that it doesn't behave very well with HotSpot. That's the problem that Twitter had with their Scala microservices. So they wrote a bunch of Scala microservices in Scala, and then they noticed that they don't know how to optimize HotSpot for it. They had problems with compilation, so the Scala compiler was becoming a bottleneck for them. And to sum it up, HotSpot, well, it's a very useful deep magic and has its own issues, but still seems to be better than other options of polyglot programming, right? And then we come to the answer of the question, what is GraalVM? Again, GraalVM is the answer to all these problems that I mentioned, or it is supposed to be the answer. First of all, it's a just-in-time compiler written in Java and exposing a Java API that is supposed to replace the C2 compiler. And it also gives you some nice knobs to fine-tune the machine code generator so that you can get better results. Okay. So, but it is more. It's also a language implementation framework. So inside GraalVM, there is this thing called TRUFFLE. That's a Java library that makes it possible to turn abstract syntax tree interpreters into efficient compilers without any additional support from your side. So basically, the idea is that you annotate your AST interpreter with some annotations, use some of the classes provided by the library, and TRUFFLE will transform it into high-performance runtime. So you can get JavaScript interpreter that is as fast as VM, or a Ruby implementation running on top of JVM that is faster than JRuby. Okay, and then the third thing that GraalVM provides is the substrate VM. Have you heard about it? Okay, so this is the answer to the cloud problems. There's also substrate VM. This is a simplified native runtime for Java that provides garbage collector, thread scheduler, and it's native. So basically, it means that it runs native code. And native image is the tool that takes your Java bytecodes, mixes them up with substrate VM, and produces a C-callable native library, DLL or SO, if you want a library, or an executable file, right? So you get .exe file on Windows, or just an executable on Unix. And the point here is that once you can do the native code thing, you don't have to pre-warm your virtual machine, because there is no virtual machine there, right? We'll get down to the details in a moment. Let's talk about those details, how it internally works. So let's talk about GraalVM, a just-in-time compiler, the one that is going to replace C2, or actually it replaces already. So there are a couple of things that it does. It does partial escape analysis. Have you heard about escape analysis? Okay, just one person, so, or maybe two. So what it is, if a subroutine, a method, allocates an object and returns a pointer to it, then this object can be accessed from undetermined places in the program, right? So it basically leaks from the context of that method. It means that the pointer has escaped. Pointers can also escape when you store them in a global static variable. Anyway, the point here is that object is available from somewhere, or might be available from somewhere else than the stack frame of currently executing method, right? And escape analysis, the one that is actually implemented in C2, it can detect cases when such an object doesn't leave the context of the method, right? So it doesn't escape. And it is one of the optimizations that C2 provides. But it only works if there is no single code path when the pointer can escape. And that was the problem they had in Twitter with Scala compiler. It generated code that in some cases, or in some code paths, the pointers escaped the context, and in some other, they didn't escape. And this basically made the escape analysis useless. But GraalVM just-in-time compiler provides a partial escape analysis that can detect those branches or different code paths and act accordingly. So if it notices that the currently executing code path doesn't let the pointer escape, it will employ the escape analysis immediately. If it notices that, okay, this was a wrong assumption, so the pointer is actually escaping from the context of this method, then it will do the appropriate stuff so that this pointer can escape. And why do we want to know if the pointer escapes or not? Because we can do things like scalar replacement. So basically, let's say that we have a point object, right? That has two member variables, x and y, right? So if the method that we're currently executing does something like, I don't know, double the x and double the y and return the sum of it. So it basically returns the circumference. It will allow for the just-in-time compiler to avoid things like memory allocation, right? So basically, we're not going to the heap with the object. Because the object doesn't leave the scope of the method, we don't need to allocate it on the heap, and then once it leaves the context of the method, deallocate it from the heap. We can put everything on native stack frame. And this makes things faster. So we can convert heap allocations to stack allocations. Once we have object on the stack, we can go even further and put some parts of the object, or the full object if it's small enough, completely away from the memory and store it only in the CPU registers, right? So we're not fetching anything from memory. We're not returning anything into memory. We just keep everything in CPU registers. So we get data locality with that. And this makes things a lot faster as well. Then the other thing that partial escape analysis provides is that it can allow lock elision, which means that if we're synchronizing on an object that never leaves the scope, what can we do? So we have a pointer, right, that doesn't leave the scope of the method. The rest of the world never sees it. What's the point of blocking the thread on what's the point of using a lock on this object? We don't need that, because no one else will ever acquire this lock. So we can speed things up, because we're not using the object monitor, right? Okay, so this is some of the things that GraalVM just-in-time compiler does to speed things up. Then let's talk about TRUFFLE, and the one particular technique that it employs to speed up execution of AST interpreters, right? So when you're using TRUFFLE, you're writing an interpreter that converts, that takes a tree of nodes and interprets them. But what you can do this with this tree, you can do the so-called partial evaluation. Do you know what partial evaluation is? So this is a very common, actually, technique that is used by compilers, right? Let's say that we have a program with a bunch of constants in it, right? Final static strings, for example. So partial evaluation means that we're going to replace all the places that this static final is used. We're going to replace with the actual string constant, right? so that we can speed things up. Or we can do things like if we have a mathematical expression that is assigned to a variable that is static, 2 plus 2, for example, right? We know the result of this addition when the program is compiled. So instead of doing this in the runtime when the class or the method starts, right, or when the class is initialized, we can replace it with a for in the code. So that's partial evaluation. And the Japanese computer scientist, FUTAMURA, he came up with an idea that we can use the same technique for interpreters, right? So let's think about an interpreted program, right? We can think of a program as a mapping between two kinds of input, a static input and dynamic input, to a result of execution of that program, to the output, right? So in case of interpreter, the static part is the script that we provide for interpreting, right? And the dynamic part stays the same. It's something that the user will probably provide, right? And what we can do, and what is called first FUTAMURA projection, is we can combine this iScript part, which is basically a constant, right? In this case. And we can use the interpreter, mix it with interpreter, and get another program that only takes dynamic input, right? And is going to be faster because we took what is constant, and instead of running it in the runtime, we precompile it, right? So that's what makes TRUFFLE-based languages so fast, even though there are script languages, right? That's the most important technique that is used by TRUFFLE library to speed things up. And then let's talk about let's talk about Substrate VM and native image tool that allows you creating native executables out of Java code. So it's actually very simple. There's only one principle here. You cannot define classes at runtime. So you have a closed world, right? This principle makes it possible to apply very aggressive optimizations, because all the code paths are known to the compiler beforehand, right? And once you get to this point that you're not defining any of the classes at the runtime, it's all defined in the bytecode. Well, there are some things like you can use some of the reflection, you can use some of the dynamic proxies, but it also needs to be known beforehand. Then it's basically static content, and you can speed things up with it. Okay, so do you think that this is a very strong requirement? Knowing everything beforehand? Why? Yeah, well, I can give you one example. Spring, right? Out of the box, Spring would not work with that, right? Because Spring creates a lot of runtime meta objects and so on and so forth, right? It uses proxies heavily. It uses bytecode instrumentation and so on and so forth. There is some work being done so that we could move all the runtime stuff that Spring does into the compilation phase, but that's not official yet. I know that there are some people working on that, but it's not official yet. But still, possible. Okay. So the final question Is it worth your time? Do you think it's worth your time, based on what you just heard? Well, let me be an advocate of devil here. This is still in research. That's research that is being done by mostly by Oracle employees, so it's basically Oracle stuff. Then, since it's Oracle stuff, there are two versions of it, the Community Edition and Enterprise Edition. And of course, Enterprise is paid for. As I mentioned before, there is no official support from Spring library, but it's a work in progress. So if you're interested in it, the question is how to get started, right? So how many of you use SDK Man? Some of you. I do use it. SDK Man allows you installing a GraalVM version of Java Virtual Machine that is based on OpenJDK 8, so a bit outdated. But if you're willing to, you can compile GraalVM on your local machine and install it into Java 9 SDK, Java 10, and so on and so forth. It's just not prepackaged. It doesn't come prepackaged. So go to graalvm.org and read all the stuff that is there, how to download it, how to install it. There are links there that allow you just to grab SDK distribution and start using it. But then, once you've got it on your box, how do I develop web applications with that if Spring doesn't support it, right? Well, my answer to that, there are some new frameworks that are based on, or maybe that mimic Spring, that are maybe worth considering. And one of them is Micronaut. Micronaut is being developed by people at OCI, that's an American company. They came up with Grails framework before, and they're actually releasing Grails 4 based on Micronaut. So I've played a bit with Micronaut. It provides a very similar to Spring Boot experience, but it's not Spring Boot, it's static. It actually uses the same technique that Google Dagger used. So it provides all the metadata as bytecode. It doesn't generate anything at runtime. So the nice thing about Micronaut is that its bootstrap time is really good. I mean, it's milliseconds, not seconds, for a typical web application. Okay, I think I'm done. Do you have any questions? Yeah, there is one question. There. Oh, I think you can flip it off for the whole execution, but not for the some parts of the code. And actually, the partial escape analyzer, it will back off if it sees that this code is not very nice thing to optimize for, right? Because in the early days of GraalVM, this was a problem for the development team because they were running into issues like, for example, the partial escape analyzer. It actually was going into an infinite loop, right? So you can turn it off as a feature for the JVM, but not for specific code paths. Any other questions? Okay. One thing that I forgot to mention, one more thing, is that you can develop applications for iOS in Java with GraalVM. There is actually a package available. You can use JavaFX for the UI and just write Java code, compile it into a native binary, and sign the application and put it into the App Store. Cool. Okay, any other questions? No questions. Thank you very much.
Oh, thank you. It was Maciej Przepióra.